In the last video, we have illustrated the concept of statistical tests. If you only want to obtain a rough understanding of the concept behind statistical tests, then the last video is absolutely sufficient. However, if you're interested in more detail, then this video will help you to understand how a p-value is calculated and what degrees of freedom means. If you haven't seen the previous video, have a look at it first. So last time we saw that statistical tests are based on two steps: the calculation of a so-called test statistic and the comparison of this test statistic with a threshold. This threshold was obtained from the distribution of the test statistic. Now we will learn some more details. First of all, when we talked about the distribution of the test statistic, this is actually not one distribution, but there are many distributions. Which distribution applies for our data depends on our sample size. In statistical terms, we don't talk about sample size, but about degrees of freedom. The term degrees of freedom sounds a bit abstract, so I will explain why we talk about freedom. When we do statistics, we often want to know about variability or variance. When we only measure a single value, we can't say anything about variability because there is no other measurement with which we could compare our value. We could say that there is no room for variability or no freedom. The more values we add to our sample, the more freedom we obtain and the more accurately can we measure variability or variance. So for a sample of 10 values, the sample variance has 9 degrees of freedom. This means there are 9 values with which we can compare our first value. However, we don't need to worry about the degrees of freedom in detail, how it is calculated. There are formulas to do that, and any scientific software will calculate the degrees of freedom automatically. We only have to understand that the degree of freedom is about sample size. Another point we omitted in the last video was the p-value. How exactly a p-value is calculated, or how we obtain the threshold, which was used to determine if a difference was significant or not. This threshold is also called the critical value. In many textbooks you can still find tables where you can look up critical values for given degrees of freedom and for one- or two-sided testing. Now the p-value is calculated from the distribution of the test statistic, which we showed last time. In this example we have marked a critical value for a level of significance of 5%, 0.05. This is shown as the red line here. So how do we obtain this line, or how do we obtain the p-value for the actual test statistic calculated from our data, the red arrow here? Well, what we want to know is how many values are below the red arrow, below our t-value. So far we have plotted the distribution as a so-called probability density function, or PDF. That is, for each test statistic we plotted the probability on the y-axis. What we need for the calculation of a p-value is another way of plotting this distribution. We use a so-called cumulative distribution function, or CDF. To illustrate what a cumulative distribution function is, maybe it's best to view our t-distribution as a histogram, just for illustration. Now, a cumulative distribution is obtained by adding up all values from the left to the right. So the first value on the left is 1. Hence, in the cumulative histogram, we also write 1. The next value is 6. If we add up this value with the previous one, then we have 7. 6 plus 1 is 7. At the next position, we have 23. Now, if we add this to 7, we have 30. And if you continue adding up all values, then at the end, we obtain such a cumulative histogram. So both graphs show exactly the same data. They just represent two different ways to show the data. Now let's go back to our original distribution. For this distribution, the cumulative density function looks like this. From this cumulative distribution function, we can now easily calculate a p-value. This is done by taking our t-value, the red arrow, on the x-axis, and looking up its p-value on the y-axis. So there we are. Using the cumulative distribution function, we can calculate our p-value. So now you know all the science behind p-values. If you liked this video, consider to like, subscribe or share. And if you're looking for an easy to use statistical software, Have a look at the GSS.